Welcome to this lecture 3 power series application of Maclaurin series. Now we want to use Maclaurin series to be able to find the series for sin x solution. Now we know that Maclaurin series is given by f of x equals to f of naught plus x times f of naught prime plus x squared f of double prime f naught all over 2 factorial plus x cubed f of naught triple prime over 3 factorial plus x raised to 4 all over 4 factorial plus x raised to 5 all over 5 factorial plus, so this is Maclaurin series. Now if we have been given sin x, so from here it means that our f of x now equals to sin x. So this is our f of x. So from here when we put x equals to 0, so here we shall have our f of naught will be equal to sin 0, which equals to 0, so we differentiate this equation. When we differentiate f of x, we get f of x prime, which equals to, so when you differentiate sin x, you get cos x, and then we put x equals to 0. So here we have f of prime naught equals to cos 0, which equals to 1, now so we differentiate cos x here. So when you differentiate f of prime, we get f of double prime x equals to, when you differentiate cos x, you'll be able to get sin x. Then we put x equals to 0. So here we have f of double prime equals to sin 0, which equals to 0. We now differentiate f of double prime, so we get f of triple prime x, which equals to, so when you differentiate sin x, you get cos x. Then we put x equals to 0. So here we have this is x. We put x equals to 0. So here we have equals to cos 0, which is equals to 1. When we differentiate this equation again, we have f of x, which equals to sin x. We put x equals to 0. So here we have this, which equals to sin, which equals to 1. Differentiate this equation again. So we have f of x raised to 5 equals to, when you differentiate cos sin x, you get cos cosh x, then we put x equals to 0, so we have which equals to cosh 0, which equals to 1. Now once we have all this, now we have f of naught raised to 5, we have f of naught raised to 4, f of triple prime, we have f of double prime, we have f of prime. So we now come and substitute in this equation. So our f of x, so we shall say that because our f of x equals to sin x, so we shall say that sin x now equals to our f of naught, our f of naught is here, our f of naught equals to 0, is equals to 0 plus x dot our f of naught prime, our f of naught prime is 1, so we have x times 1. So we have done this, that one, then plus x squared times our f of double prime. Our f of double prime is 0, so times 0, so we are done with that one. Then plus x cubed times f of triple prime. F of triple prime is 1, it's 1. Then f of triple is 1 times 1, but we have over, remember we have over 3 factorial, and x, this one is over 2 factorial, so we are done with this one. Then plus x raised to 4 times f of naught raised to 4, where is it? It's here, raised to 4, raised to 4 is here. When we put x equals to 0, so sin 0, this is 0, so this will be times 0, times 0 over 4 factorial, plus, now we are on this one, plus x raised to 5 times, now we have f of raised to 5, which is this 1, so it will be 1 over 5 factorial. Therefore sin x would be equal to, this would be 0, so we have x times 1, we have x, then plus, this would be 0 because we are multiplying with 0, so this would be 0, this would be 0, then we have plus x cubed all over 3 factorial because x cubed times 1, then plus, we are multiplying with 0, so this will be 0 there, so we remain with plus x raised to 5, of course, times 1 all over 5 factorial plus. So as you can see, this is now the series for sin x equals to x plus x cubed all over 3 factorial plus x raised to 5 over 5 factorial, and it continues like that. You can see that there is a pattern: x raised to 1, x raised to 3, x raised to 5. So there are odd powers of x, so it will be, the next will be x raised to 7, of course, all over 7 factorial, etc., etc. Thank you for watching.